You've learned a lot about electric circuits. I think it might be time to consolidate them all and practice a few together to make sure that we understand how voltage, current, resistance, work, power, and internal resistance all fit together. Let's hop right in. In this diagram, we're given electrical devices X and Y. They're connected to a 24-volt battery with internal resistance R, as shown in the circuit diagram. The power rating of each of the devices X and Y is indicated in the diagram. With switch S1 closed, the devices function as rated. The first question asks, if the power rating of resistor X is 100 watts and the potential difference across resistor X is 20 volts, then calculate the current flowing through resistor X. Here we have the power, 100 watts, and the potential difference of 20 volts. Thus, using the power equation, P is equal to V times I, substituting in 100 is equal to 20 times I. Then solving for current, we get I is equal to 5 amps. The next question asks, calculate the current flowing through resistor Y. Here we have the power, 150 watts, and the potential difference of 20 volts. Thus, using the power equation, P is equal to V times I. Substituting in, 150 is equal to 20 times I. Then solving for current, we get I is equal to 7,5 amps. The following question asks us to calculate the total resistance of the external circuit. First, we need to add up the currents from the parallel branches to get the total current. The current external is equal to 5 plus 7,5, which equals 12,5 amps. Now we can calculate the resistance, remembering that voltmeters in parallel are equal. Thus, resistance is equal to potential difference divided by current, which is equal to 20 divided by 12,5. This equals 1,6 ohms. The next question asks us to calculate the internal resistance of the battery. Here we can calculate the internal potential difference by subtracting the potential difference of the external circuit from the EMF. Thus, 24 minus 20 gives us 4 volts. Now we can calculate the internal resistance by dividing the internal potential difference by the current. Thus, 4 divided by 12,5 is equal to 0,32 ohms. Here's a really tricky question. Bulbs that you buy from a supermarket or hardware store to light your home usually assume that you'll be supplying 220 volts to them. If you supply them with the rated voltage, they give out the correct amount of power. The power usually tells you about the brightness of the bulb. There are different types of bulbs on the market designed to save us money. Let's use calculations to see if they actually do save us money. The two light bulbs shown have got different power consumption values. The incandescent bulb on the left gives out less light for the same power, so it uses more electricity. That costs money and is not sustainable for the energy production in industry. Bulb 1 costs 9 Rand and 50 cents and consumes 40 watts of power. Bulb 2, a new energy-efficient type, consumes only 4 watts to produce the same amount of light, but it costs 30 Rand. The question asks, how long would bulb 2 have to operate to begin saving money? Let's assume that the unit price of electricity is 1 Rand and 30 cents per kilowatt hour, and our answer is rounded to the nearest hour. Well, let's start by saying that the saving of money includes buying the bulb. So for bulb 1, that means 9 Rand 50 plus 0.04 kilowatts multiplied by time multiplied by 1 Rand 30 for each kilowatt hour. For bulb 2, that makes 30 Rand plus 0.004 kilowatts multiplied by time multiplied by 1 Rand 30 for each kilowatt hour. Now, we only start saving when the cost of buying and using the 2 bulbs is the same. That's a simultaneous equation. If we make the cost of bulb 1 and bulb 2 the same, we have only the time value to figure out. The maths is a little tricky though. We need to move the terms containing time to be on their own. Then we factorize out time. When we divide both sides by the brackets, we find that the second bulb becomes cheaper after using it for 188 hours. I know electric circuits can be tough, but remember, it just takes patience and practice.